Hello everyone. Welcome to Menta. My name is Pranay Sharma and I'll be your lecturer for this term. So the topic that we'll be considering today is polynomials. It is going to be session number 1. And these are our learning outcomes. That means by the end of this session, we will be defining what do we understand by algebraic expressions and what exactly the definition of polynomials is, degree of polynomials and many more. Right? So let us get this started. All right. So the slide that is being displayed, I hope it is visible. It is giving you a crux of what we have already covered in grade 8, right? What exactly are variables and why do we call them as variables? Because they have the capacity to change their values. For me, suppose if I am solving a question related to ages, right? So for me, the number, whatever the answer that I'll be, arriving after having multiple approaches followed, that will be in ages, right? 27 years old, that will be in years. However, suppose if you are considering it for a different section, that means if you are solving a question pertaining to speed and the question belongs to speed, time, and distance, then for you it will be either in meter per second or kilometer per hour, right? These are the standard units that we follow. So that means they have the capacity to change themselves, right? For me, X may have a different value and a different unit, and for you, X may have a different value and a different unit. That depends on the type of question that you are considering and the type of question that I am considering. Constants are the ones whose value remains the same, right? The value will not be changing. Suppose if we are, giving you a number, let us say 5, then the face value of 5 is 5 itself. Its value will not be changing in due course. Fine. What do we understand by coefficient? Suppose in this example, if you can see it clearly. If you traverse it from left to right, 3x is something that we are given with. So it is a combination of constant and a variable. If suppose someone is asking you to calculate the coefficient of x, then you need to simply divide that particular expression by x. All right, let us consider this by switching ourselves to whiteboard. So I'll be using black marker. Let us consider an example 5x and somebody is asking you to calculate coefficient of x. So what you'll have to do, you pick this term and they're asking you to calculate coefficient of x, divide this term by x. Whatsoever you will be, getting, that will be your coefficient of x in 5x. Fine. So this is just a normal example. Suppose if we are given with 3x square plus 2x plus 1, right? A quadratic polynomial. I'll tell you what polynomials are, but for as of now, you can consider this that yes, it is going to be a quadratic polynomial. That's it. Fine. And I'm representing this as p of x. Fine. If suppose somebody is asking you to calculate coefficient of x square, then you need to traverse it from left to right. Check which term is having x square. Once you have identified that this term is having x square, take this term out of the context, out of this, right? And then divide it by x square because that is what you are asked to do. Once you perform the cancellation, the answer that you are left with is going to be your coefficient. I hope this is clear. Let's move back to our slides. Operators plus, minus, division, and multiplication. But practically, mathematics runs on two operators, plus and minus, right? Multiplication is nothing but addition, and division is nothing but subtraction. Fine. So, in order to consider this, let us move to our whiteboard again. Expressions. Whenever we have a constant and a term, and when we join them with an operator, right? Multiplication or division. Let us say multiplication. So we have 5x. This combination is known as a term. All right. Constant and a variable. Either they are connected with multiplication or they are connected with division, right? You can also have 5 by x or x by 5. So that will also be considered as a term. Can 5 alone be treated as a term? Yes, because 5 can be written like this. 5 into x to the power 0 or 5 divided by x to the power 0. Again, multiplication and division. That is what we need, right? X to the power 0 is what? 1. Anything that raises to power 0 is 1 except 0 to the power 0. So that is what we are considering here, right? Can x alone be treated as a term? Yes, because this can be written as a combination of constant and a variable in this format. Fine. So this can also be treated as a term. However, if you connect them using plus or minus x 5, you are connecting them using plus. So this will give you x plus 5. This is nothing but an expression. Rather, I should say linear, algebraic expression, although it is linear in nature. Linear means the maximum power of a variable is fine. So let's move to our slide back. These are the parts of an algebraic expression. We have terms connected with an operator, plus or minus, coefficient, variable, and constant, right? Few more examples. 7x square minus 9x plus 3 quadratic. 3xy minus 7z plus 8. Then x square plus 7x plus 9 divided by 3x minus 7. Now division is allowed in algebraic expression, right? We can have two different terms getting connected with division or multiplication. Ultimately, that will be resulting as an algebraic expression. Fine. Now they're asking you what is the coefficient of x in 4x. So again, we'll move back to our whiteboard. Coefficient of 4x. Coefficient of x in 4x. Take this term, divide it by x. Whatever you are left with is going to be your coefficient. Right? I hope this is clear. So answer is 4. Calculate. What is the coefficient of ax square in, what is the coefficient of x square in the polynomial ax square plus bx minus 7? So what I'll do, I'll be, quickly jumping to timer, right? I should be putting a timer of, let us say, 2 minutes. Let me start the timer. I'll be minimizing this as much as I can, right? However, it is not required that you should see the timer because you will be, getting a beep sound. I want you to please go through with the question because this is the only way possible in which we can, have the needful done. This is the simplest question. Whatever the steps that I asked you to follow, please follow those steps. One more minute. All right, time is running out. 10 more seconds. So time is up. Right. Let us move to our whiteboard. Question was ax square plus bx minus 7. They're asking you to calculate coefficient of x square in this. First, to scan it from left to right, identify the term that has x square in it. Take this term out, right? They're asking you for x square, divide this term by x square. This and this will go away. You're left with a. A is going to be a coefficient. And remember, coefficient can also be in variable format, right? That is what we have learned from this example. All right, let us go with slideshow. So what we have studied about algebraic expressions, I hope that is clear now, right? Interconnection of two terms. However, alone can also be treated as an algebraic expression because 9 can be reconfigured as 8 plus 1, right? 8 plus 1, that means 8 plus x to the power 0. Or it can also be written like this, 9 by to the power 0 divided by x to the power 0. So these are all polynomials, but we'll move to standard definition of polynomials, what exactly it is. So algebraic expressions, in algebraic expressions, we have seen that yes, division is allowed, as you can see this, right? The third one, division is allowed. Fine. But in order to have an algebraic expression as a qualified polynomial, we need to follow two rules. Now, please note down these rules. The power of each variable in the expression should only be a whole number. That means if suppose something is given to you as 2x to the power minus 3, then that is not going to be a polynomial because this violates rule number 1. Rule number 2 is division by another algebraic expression is also not considered, that is also not considered as a polynomial. If we are given with an algebraic expression where this division is something that we have, then we'll not be considering this as a polynomial, right? The third one is not a polynomial. Likewise, they have given an example as well, 2 divided by x plus 2. Again, this is not considered as a polynomial. Ultimately, if you try to use exponents and powers, and if you can rewrite this, so it will be 2 into x plus 2 to the whole power minus 1. Power should not be negative. So this will give what is a question to rule number 1 again, right? So that is not something that will be considered. So 2x cube minus 7x plus 9 is a polynomial. However, 2 divided by x cube minus 7x plus 9 is not a polynomial because when you shift this x cube in the numerator side, it will become x to the power minus 3, right? Negatives are not allowed. Power has to be whole number. Remember rule number 1? So polynomial is an algebraic expression that consists of variables and coefficients that involves only operations of addition, subtraction, multiplication, and whole number exponents. Right? Division is not allowed. And this is the general way in which we express a polynomial. A is a coefficient of x to the power n. A n is the coefficient of x to the power n. Likewise, a n minus 1 is a coefficient of x to the power n minus 1. Right? And so on. And this will go till a naught. Denotation means how do you denote the polynomials? So either you can follow, if suppose your polynomial is given to you in x variable, so it will be p of x, q of x, r of x, right? If it is in y, you can consider any denotation which you want. R of y, s of u, it depends on the variable. Fine. Check whether this is a polynomial or not. Now, many of you will think that division is not allowed. This is definitely not a polynomial. So let us take this example on our whiteboard in order to understand this. All right, I'll be using a different marker because this question is very interesting and I don't want to disturb the dignity of what we have, already covered in the whiteboard in upper half. X to the power 3 by 2 and then we have root of x. So people, what do you understand by root of x? Right? Root of x means this can, just a second. This can be written like this, x to the power half. Half is nothing but root of x. Root of x can be written like this. Right? This is something that we have seen in 8th grade. X square plus, don't you think this is nothing but uh, it obeys a to the power m divided by a to the power n, which is nothing but a to the power m minus n. A is same, so here x is same, bases are same, powers have to be subtracted 3 times x to the power 3 by 2 minus 1 by 2. Now what is 3 by 2 minus 1 by 2? 2 is the LCM, it will be 3 minus 1, that is 2 by 2, that is nothing but 1. So this will be x square plus 3x to the power 1 is x only. This is a polynomial. That is it. Fine. So the question was simple, although it was drafted in a typical language. Now we'll come to degree. What do we understand by degree of a polynomial? Degree means the highest power that a polynomial is having. So 3x square plus 7x plus 8. The highest power of a variable is what? 2. So 2 is the degree. And accordingly, we'll be classifying this polynomial as quadratic polynomial. For 3, it will be cubic polynomial. For 1 degree, it will be linear polynomial. And so on. Right? So that is it. Thank you for the day. In case if you have any question which is to be reconsidered, this is just an introductory session. You can write it down and then we'll be considering it in next session. Thank you so much. Bye. Take care. Stay safe.